Okay, so today we'll discuss the first topic from module 6, that is queuing theory. Queuing theory or queuing model. Okay, so what do you understand by the word queue? Have you heard anywhere queue? What is queue? Or queuing like situation, queue like situation. Have you seen somewhere in practice? Yes or no?
Yes, sir.
Where you have seen it?
Ticket counter.
Your voice is not clear. Row number 14.
Ticket counter.
Ticket counter, yes, okay. Ticket counter, one thing. Second, anything else? Ticket counter, say at bus stop, say at movie theater, say at any other place where tickets are issued. Okay, one thing. Second, फक्त ticket counterलाच. बाकी कुठं क्यू बघितलं नाही.
Sir, admission in colleges.
In colleges while taking the admission, while paying the fees and all these things. Okay. Vaccination center, yes. So nowadays you can see the queue lines at vaccination centers. Those can be managed very well if this kind of problems are given to professors like me. Okay. Okay. Next. Anything else outside? Somebody has written somewhere. Outside shops. Okay. Outside shops, say grocery stores, malls. Okay. Anyway, anything else? Playlist of songs. Okay. These are nothing but in queue. Okay.
So
So
queue of vehicles.
queue of vehicles waiting for servicing, waiting for delivery. Okay. Or waiting at the signal. Anything else? Okay. In bank, have you observed the queue? Yes or no? So
Yes.
bank counters, post offices, hospitals. Okay, even as somebody has told that a playlist waiting for a song. Similarly, there may be situation like jobs are waiting for to be processed. So for manufacturing is concerned, okay. So the job are waiting on one machine or in between the machines, and even they are waiting for getting inspected or tested, and then they are waiting for packaging, dispatch, and whatnot. Okay, so everywhere if you go, queue is there. In if you go for manufacturing sector or if you go for service sector, everywhere you will find something is in queue. Even in software, if you will find that what data is in queue. Okay, if you execute some commands parallelly, see they may be in series or parallel, they will remain in queue. After execution of one, the other will get executed. Kind of things are there. Do you agree with me? So whatever is there required processing, something required to be processed. That process may be anything which we want to follow, which will rather add value to the system. That is nothing but the queuing system. Are you getting? So this problem again comes under the purview of operations research. People thought of finding out the solution to this kind of problems. So what are the important things if you look at a queue or queuing system? If you see any queuing system, you can imagine anything. What are the characteristics of it? What are the elements of it?
Discipline.
Queue discipline. Okay, one thing. You directly come to a major element of queue. Who has told queue discipline?
Sir, me.
I did not hear. First in, first out, that is FCFS. first come first serve, that is one type of queue discipline. It comes under queue discipline. Anything else? Queue discipline is there, but before that, some sort of calling population or input source is there from where the items are, from where the components or jobs or labor or men or whatever it may be is coming. So there is a calling population or input source from where something is coming and getting attached to the queue. Okay, so that is called as calling population. Respective order. Respective order. Okay, it will be in order only, or that will remain in the queue. That is one thing. Then after calling population, there must be something like queue, what we can call it as queue configuration rather. Okay, so queue configuration where waiting area is there and queue get configured, and then whatever is coming out of that will join the queue discipline, and then from queue discipline it will go to the system where service mechanism is there. Okay, so from queue mechanism to the service mechanism where uh, product being served, or if it is service sector, customer getting service or being served. Okay, and after that, what will be the outcome or output of this particular system? What will be the outcome or output of this particular system? A served customer, a finished goods, a completed job. Am I right? So that is the outcome. That is the outcome of the queuing system. And we are interested in one thing is something is required to be processed. It will come and join the queue configuration or come into the queue configuration. It will follow some queue discipline. It will go to the service mechanism, gets the service and come out as a serve customer. So these are the things present in any queue system if you see. Now, if at all we want to discuss about the cost incurred for the queue system, what are the costs you think? Only if we think about the queuing system or queue only. Can you tell me? Can think of anything related to that? Okay, one thing is cost offering the service. Cost of offering the service. Cost of offering the service. And second is cost incurred due to delay in offering the service. Cost incurred due to delay in offering the service. Delay in offering the service. Delay in offering the service. Okay. Now, what do you think cost of offering the service will include? This will include cost of offering the service will include facility cost plus operating cost. So whatever facility which will provide the service, its cost plus operating cost, operating that facility. Okay, so it is related with the service mechanism. And then cost incurred due to delay in offering the service will be calculated in terms of what? Cost incurred due to delay in offering the service. How you can decide that? What will happen if delay is there? That means customer has to wait in the queue for the long time. What will happen? What are the possibilities?
Less task will be done.
Less task will be done, rather customer will leave the queue and will go to the other dealer. Am I right? Or service provider.
Yes, sir.
So loss of customer may be there. That is one.
Loss also be there, sir.
That is one possibility. And secondly, what is the another possibility? If suppose job is there waiting in the queue. If long queue is there, there will be loss of production. It may be in terms of time, cost, or whatever it may be. Are you getting? So that comes under cost incurred due to the delay in offering the service. Now, if you consider cost of operating the service facility per unit time and cost of waiting customer per unit time, then we have to make trade-off between that. And that trade-off will give us the optimum strategy or optimum service level. Okay, so how they behave? They behave something like this. If suppose we consider the cost on one axis, say cost is considered here, and level of service on other axis. So level of service. Then the cost of waiting customer per unit time. As the level of service increases, the cost of waiting customer per unit time will increase or decrease.
Decrease.
Yes, pardon?
Decrease.
Decrease or increase? I am not getting you.
Decrease.
Decrease, yes. So it will follow certain pattern. Suppose this is following in this way. So this is nothing but cost of waiting customer per unit time. Cost of waiting customer per unit of time. It will decrease. Level of service means if suppose you are going to the bank and there is a queue at say counter, and if queue is longer, if they increase the number of counters, the queue will become shorter at each counter. Are you getting? So level of service will get increased and cost of waiting customer per unit time will get decreased. Then cost of operating the service facility per unit time. What will happen if level of service increases? For operating that service, it will increase or decrease?
Increase.
It will increase. It will increase, suppose in this manner. So this will be cost of operating the service facility. Cost of operating the service facility. Because based on the number of customers coming into the queue, we are increasing the level. Means we are increasing the number of counters, say. So cost of operating the service facility will increase. Because for opening another counter, we will require one more service provider. Some other facilities related to that are required to be added as well. So this is per unit time. Okay. Now, if you superimpose these two, the total cost will behave like this, and it will be minimum somewhere at this point. And this is nothing but the optimum service level. This is the optimum service level. And what is that? This is total cost or total expected cost. And it will be minimum at this point, somewhere here. Okay. And this is the behavior. So we are interested in what? We are interested here at this point. Otherwise, what will happen? If number of customers are less and we are offering more number of counters, it will not be useful. If number of customers are more and we are offering only one counter, it will not be useful. Are you getting? So we have to go for trading between these two. So nowadays you might have seen at bank or everywhere, multi-skilled persons are required. Why? Because if suppose they must be able to handle different types of services or counters, so that whatever is needed, they can provide the services at that place. Are you getting? So multiple skills are required to be acquired, so that a same person can work at different counters. If suppose one counter is closed, nobody is there to serve, then that person can go to the another counter where there is a rush or long queues there, so that that counter can be open. So multiple kind of skills are required to handle this kind of scenarios or services, or even in manufacturing as well. So that point of view, this is the scenario nowadays. Okay. Now, if we go for next thing, what I discussed what are the elements of the rather this particular queue system. First is input source, as I told you. Input source. Suppose this is the block diagram. Here there will be input source. Then from input source it will go to queue configuration. This will be your queue configuration. And then it will go to service mechanism. Service mechanism. Or service process. Okay. Then what will be there? Departure. There will be departure. Or at the departure, what is there? Served customer will be there. Okay. So if suppose this input source is nothing but the calling population. Calling population. Now, as I told you, the calling population may be finite or infinite. Okay. Or calling population may be in such a way that the queue will always go on increasing and system will never be uh, empty. It is always under working condition. Okay. Now, if suppose at input source, what we will get? We will get the arrival process. How the customer arrives. Now from calling input source, the customer comes, and before going to the queue configuration, if it goes out, then it is called as balking customer. BALKI. Balking customer. Okay. Now this is nothing but the waiting area where the customer is waiting. Now customer goes into the queue configuration, wait for some time, and think that no, I will not continue this queue and will go out. That is called as reneging or renege. Okay. Now once the queue configuration, from queue configuration it goes to the queue discipline. Queue discipline. Okay. While going into the queue discipline, instead of continuing it, if it goes, then it is called a jockeying or jockey customer. Okay. Then it will go to the service mechanism. It gets served and it will come out. So there are two things. One is some sort of arrival process or arrival distribution is required from statistical point of view or from mathematical point of view. And then some sort of service distribution is required from statistical or mathematics point of view in order to produce or prepare a mathematical model for the queuing system. Are you getting these things? Are you getting this thing? Okay. So what we know, we should know what sort of calling population is there and from in what manner the customer is arriving and what kind of service providing facility is providing the service so that it can be fit into some sort of statistical distribution. So if you know that, then and then only it can be modeled properly and it can go ahead. So such types of models are available so far queuing theory is concerned, and only one such model is included in your syllabus and related formulae to that model are included, and we are going to discuss that model only. Are you getting me? Is it clear?
Yes.
Okay. So if it is the case, then how to term that model or what kind of notations are used that model for that model? So there is one person called as Kendall who has given the notations. So this is called as Kendall's notation. Kendall's notation for queuing models. Okay, so how he has given the notation? He has mentioned it in this manner: A oblique B oblique C colon into bracket again D oblique E oblique F. So this is the model, Kenda's model. Yes. What this A indicates? A is nothing but the arrival distribution. Arrival distribution. What is next? B. B is nothing but the departure or service time distribution. Departure. Are you taking all these things? Yeah, write down this. Service time distribution. It is very difficult to write on the screen, but I am trying somehow. So then next C is nothing but service or queue discipline. Service oblique queue discipline. Okay, then D is nothing but no. C is not queue, service or queue discipline. Yes, this is wrong one. D is service and queue discipline. C is number of parallel service channel. Number of parallel service channel. There may be only one service counter. There may be parallelly 2, 3, 4 service counters. So how many number of service counters or channels are there? Based on that, you can think it is in series or parallel. Okay, so number of parallel service channels. And then D is nothing but queue discipline. Service or queue discipline. Then E. E is nothing but maximum number of customers allowed in the system. Maximum number of customers allowed in the system. So when I say system, system always includes queue plus service. म्हणजे क्यू मध्ये असलेले कस्टमर प्लस सर्व्हिस मध्ये असलेले कस्टमर दोन्ही मिळून जे असते दॅट इज कॉल्ड ॲज सिस्टम. सो मॅक्सिमम नंबर ऑफ कस्टमर्स allowed in system q plus service. And next is f. F is nothing but calling source or calling population. It is called as calling source, or it is also called as calling population. Is it okay? Now arrival distribution, what kind of distribution is there? So in our case, we are going to consider it as a Poisson's distribution, which is equivalent to exponential distribution. Okay, D, departure or service time distribution, that is also exponential distribution in our model 1, which we are going to consider, and that is included in your syllabus. Next, number of parallel service channels, we are going to consider only one service channel, so 1. And D, service or queue discipline, here we are going to consider FCFS only, first come first serve. Okay, what are the other service channels? Can you tell me? Queue disciplines, somebody has told FCFS. Is there any other? Is there any other?
So reverse, last come first serve.
LCFS, last come first serve. म्हणजे आपण स्टॅक करतो ना, समजा बिलेट असे प्लेटवर प्लेट जर स्टॅक करत गेलो तर आधी आलेली प्लेट खाली बसणार, त्याच्यावर दुसरी, त्याच्यावर तिसरी. पण when we want to use it, we will remove the last one which is at the top. That is called as last come first serve. Is there any other? It is called as SIRO, SIRO, service in random order. Randomly we can pick anything and that will go into the service. Then next one is priority service. Some sort of priority is already decided. If that kind of person comes, the priority will be given to this particular thing. Okay. For example, if suppose we are in the queue, say in bank counter, and suppose some MLA comes into the bank, whether he has to wait in the queue or he will get service directly. Actually, what should be there, that is a different case. But what is the general practice, that I am asking.
Sir, maybe prioritizing.
Prioritizing, considering him as a VIP, he will be given the first preference. So that is called as priority service. Then preemptive priorities, it is based on the emergency. Sometimes in hospitals, if emergency patient is there, he or she will be given the first priority. So that way they are different. But here we are going to consider FCFS. Then next is maximum number of customers allowed in the service. Infinite number of customers are allowed, that we are going to consider. F is calling service and population means input source. That is also infinity, which we have considered. Now, how to represent that model? That model is indicated as M1 FCFS infinite. This is the model that is called as model 1. There are other models as well. That model is included in your syllabus and we are going to discuss this. M1 FCFS infinite. Is it okay?
Yes, sir.
Now for this model, there are some formulae, about 15 formulae are there. So you just take down those directly. So based on certain criteria, some sort of derivation, based on some sort of distributions they have been considered and derived, we'll directly take the equation for these different terminologies. Is it okay? So that you can use one or whatever is asked in the problem, based on that you can use one or more of the equations or formula and then you can solve the problems. Is it okay? Is it
Okay, sir.
okay? So first you take down the first formula, that is called as traffic intensity or utilization factor. Traffic intensity. So the first one is, you just write down the name traffic intensity or utilization factor. I'll not write all the things. So how it is denoted? It is denoted by rho. What is the formula for that? Formula is lambda by mu. Okay. And this rho is always less than 1. Why? Because lambda is nothing but mean arrival rate. And mu is nothing but mean service rate. So it is nothing but mean arrival rate divided by mean service rate. Okay, it is called as traffic intensity or utilization factor. So formula number 1. And the next two, this lambda is also called as average number arrived per unit time, or mu is also called as average number of customers served per unit of time. Okay, then next you just take down probability of n number of customers, probability of n number of customers in the system, probability of, are you writing no?
Yes, sir.
Okay, probability of n number of customers in the system, that is denoted by P of n. So P of n is equal to rho raised to n into bracket 1 minus rho. How it comes? You just write down there only in the second formula only. Probability of infinite number of customers. Probability of infinite number of customers in the queue is equal to probability of 0 customers in the queue, probability of 1 customer in the queue, probability of 2 customer in the queue. Similarly, up to probability of infinite customer in the queue is equal to what? Addition of this
1.
1. So probability of all this is nothing but 1. Now, if you use the first formula, P of n is equal to rho raised to n into 1 minus rho, then what will be the probability of 0 customer into the service? Probability of 0 is equal to rho raised to 0 into 1 minus rho. Rho
1
raised
minus rho.
1 minus rho. So it will be 1 minus rho. Similarly, if suppose we go for probability of 1 customer, then it will be rho into bracket 1 minus rho. Probability of 2 customers will be rho raised to 2 rho square into 1 minus rho, and so on up to probability of n is equal to rho raised to n into 1 minus rho. Is it okay? Now take down formula number 3. Probability of non-empty queue. Probability of non-empty queue. Into bracket you can write server being busy. Non-empty queue म्हणजे काय? Server busy असेल तर queue will always be there. So the queue will never be empty. That means it is non-empty queue. So probability of non-empty queue means server being busy. You can write into bracket server being busy. So probability of non-empty queue means probability of n is greater than 0. So that will be equal to 1 minus what? Probability of n is greater than 0 is equal to what? 1 minus
Probability of
0, probability of 0. So it will be 1 minus into bracket 1 minus rho. So it will be rho. That is utilization factor or intensity. Okay, so this is the third formula. Next you take down fourth one. You just take down expected or average number of customers in the system. Or rather, I will show you the next formula in my notebook only. Okay, so here whatever is there at number 3, no, you just take it as number 4. Okay, so whatever, is it visible to you people?
Yes, sir.
Okay, so whatever is at 3, no, you call it as 4. Expected into bracket average number of customers in the system. In the system means queue plus service. So expected or average number of customers in the system, it is denoted as LS. LS is equal to rho divided by 1 minus rho. If you put rho is equal to lambda by mu, then it will become equal to lambda upon mu minus lambda. So take down this third formula as the fourth one. Expected or average number of customers in the system. LS is equal to this. Have you taken this? Yes or no?
yes, sir.
Okay, next formula number 5. 4 आहे तिथं 5 करा. Expected or average queue length means what? Expected number of customers waiting in the queue. Expected or average queue length or expected number of customers waiting in the queue. It is denoted by LQ is equal to rho square divided by 1 minus rho. Now if you put rho is equal to lambda by mu and simplify it, it will become equal to lambda square divided by mu into bracket mu minus lambda. Okay, now take down sixth formula. Expected, here sixth means fifth from this page. You write it at sixth. Expected or average waiting time. Expected or average waiting time in the system. Into bracket you can write waiting plus service. System means waiting plus service. So expected or average waiting time in the system, into bracket waiting plus service. It is denoted by WS. So WS is equal to 1 upon lambda into bracket rho divided by 1 minus rho bracket complete. If you put rho is equal to lambda by mu, it will become equal to 1 divided by mu minus lambda. Okay, now formula number 7.
सर यूनिट क्या है सर?
Yes?
यूनिट क्या है सर? एक्सपेक्टेड टाइम
नाही, तुझा आवाज येत नाही आहे नीट.
सर
कुणाला
यूनिट काय आहे सर?
unit? Okay. So expected waiting time. Time will be, if it is given in seconds, it will be second, hours, hours, minutes, minutes.
ओके सर.
And if length of queue means number of customers, it is just number.
ओके सर.
And time is in time units. Okay. Okay. Now seventh one. Expected or average waiting time of customer in queue. आता formula number 6 तुम्ही काय बघितला in system. Now it is in queue. Expected or average waiting time of customer in queue, that is denoted by WQ, which is equal to 1 by lambda into bracket rho square divided by 1 minus rho, which is equal to lambda divided by mu into bracket mu minus lambda. You can use either of these in terms of rho or in terms of lambda and mu. Okay, I'm giving you both. Have you completed this? इथपर्यंत झालं का?
Yes sir.
Okay, now 8th. Average length of non-empty queue. Average length of non-empty queue. Or it is also called as expected number of customers served per busy period. Expected number of customers served per busy period. It is denoted by LP is equal to expected number of customers in the system divided by probability of system being busy. So expected number of customers in the system is LS divided by probability of system being busy means probability n is greater than 0. So which is equal to LS divided by 1 minus P0, which is equal to LS divided by rho. What is LS? Put the value formula for LS. LS is shown here. Formula number 4. So if you put that, it will become equal to 1 divided by 1 minus rho. Or in terms of mu and lambda, it will be equal to mu divided by mu minus lambda. So this is also called as average queue length that is formed from time to time. This LB is also called as average queue length that is formed from time to time. Why I am giving you this R as well? Because in some problems, it is asked that find out average queue length that is formed from time to time. So which formula you have to use? You should remember that. From that point of view, I am giving all the R and all this thing. Okay. Is it okay? So if it is asked that find out average length of non-empty queue, same formula. If it is asked that expected number of customers served per busy period, same thing. If it is asked that average queue length that is formed from time to time, same thing. Okay. So for that I have written R and all these things. Okay, now formula number 9. Am I right? Have you completed LP?
Yes sir.
Okay. Take it fast. Up to 4:30 we have to finish 15 formula. Okay, formula number 9. Expected waiting time in the queue for busy system. Or average waiting time in non-empty queue. Or average waiting time of an arrival who waits. So it is denoted as WB, which is equal to expected waiting time of a customer in the queue divided by probability of system being busy. So expected waiting time of customer in the queue is WQ divided by system being busy is 1 minus P0. So WQ divided by rho. So if you put the formula for WQ, which is previously given to you, then it will become equal to 1 divided by lambda into bracket rho divided by 1 minus rho, bracket complete. If you write it in terms of lambda and mu, it will become equal to 1 divided by mu minus lambda, which is same that as of WS. See the formula of WS which we have previously discussed. So WP is nothing but equal to WS. The same formula. So the terminology is different and derivation is also different. But the equation comes, the formula comes as the same. Okay, then 10th one. Have you completed this? WP is completed? Yes or no?
Yes, sir. Yes, sir.
Yes, sir.
10th. 10th, write down variance of a queue length. Variance of a queue length. Sometimes it may be required, or if not, it will be required in some other calculations. So just return. So variance of a queue length, it is denoted by var into bracket n, which is equal to rho divided by 1 minus rho bracket square, which is equal to lambda mu divided by mu minus lambda bracket square. Now next, 11th one. I think 11th. Variance झालं का? Okay, 11. Probability density function of a waiting time excluding service distribution. Excluding service means only waiting time. So probability density function of waiting time excluding service distribution is equal to rho into bracket mu minus lambda bracket complete into e raised to minus into bracket mu minus lambda bracket complete into t. So e raised to that minus term. Okay. Now if suppose time t is greater than 0, then it will remain as it is. And if time t is equal to 0, then this formula will become equal to rho into bracket mu minus lambda only. Okay. Have you completed this? Have you completed?
Yes, sir.
Okay, now 12th one. Probability density function of waiting plus service time distribution. Previously it was only waiting time. Now here probability density function of waiting plus service time distribution is equal to into bracket mu minus lambda bracket complete into e raised to minus into bracket mu minus lambda into bracket complete into t. So here the rho term is not there. If you compare it with the immediate previous equation, rho term is only not there. So this is probability density function. Then 13th one. Probability of queue length. Probability of queue length being greater than or equal to n. Probability of queue length being greater than or equal to n. N is nothing but the number of customers. So probability greater than or equal to n is equal to rho raised to n, which is equal to lambda by mu raised to n. Okay, now before going for some problems, 13 formula झाले ना? झालं काय सगळं लिहून?
हो सर.
Okay. So next take down 14, formula number 14. Or I will write it previous. Formula number 14. Probability of waiting time in queue. Probability of waiting time in queue greater than some value, greater than, that means greater than W. So probability of waiting time in queue greater than W. You can write that W into bracket only. Okay, sometimes say 20 minutes. What is the probability of waiting time in a queue is greater than 20 minutes. If you find that, we can decide that whether we should remain in the queue or not. Because if we are having 10 minutes at hand, we can't wait for 20 minutes. So this kind of probabilities are required to be found. So this is denoted by the, like this, probability of T is greater than or equal to W is equal to integration of W to infinity lambda by mu or rho into bracket mu minus lambda into e raised to minus into bracket mu minus lambda bracket complete into t dt. Okay, so by using this formula, you can find out the probability of t is greater than some value for q, waiting time in q. Have you taken this formula?
Yes sir.
Okay, now next 15, formula number 15. Probability of waiting time in system greater than W. Probability of, previously it was in Q, now it is in system. Probability of waiting time in system is greater than some value W. It can be denoted like this. Probability of T is greater than or equal to W. Here T is T system is greater than or equal to W is equal to integration W to infinity mu minus lambda e raised to minus mu minus lambda into t dt. Is it okay? Only thing is that probability density function is used here along with the integration. That's all, up to infinity. Okay. Otherwise, probability density function formula you already taken for Q as well as for system. The same formula is used in for formula number 14 and 15 along with the integration. Why? Because we want to see above W up to infinity what is the probability of waiting. Okay, so integration is there. Is it okay? Have taken this?
Yes sir.
सर 14 दाखवा थोडा.
काय तुझा आवाज येत नाही, कोण बोलत होतं त्याचा काय मला
सर 14 दाखवा.
मोठी. Okay, have you taken this?
Yes sir.
Completed this much? Okay. So I will stop presentation.